In this video, we are going to continue our discussion on section 4.4, percents and compounding. In particular, this video will address our second objective, how you can incorporate change, focusing mostly on multiplication. And thus, we know that percents are typically used to keep track of changes. Classic example is Wrench's sales are down 22% from last year. The NBA's collective bargaining agreement will grant players 80% more money than the previous collective bargaining agreement. Anytime something changes, you can keep track of the quantity of change using a percent. All of these examples, 6, 7, 8, 9, 10, 11, they're all about keeping track of that change. So first of all, how does a 9% increase correspond to the original? Well, of course, it's 9% more. How would you write that out with a mathematical expression? Perhaps the most important distinction you need to make when working with percents, there is a huge difference between percent of and percent change. They're not the same thing. Many students struggle recognizing when a problem is having you work with percent of versus percent change. Many students will struggle incorporating them in the problems. It is one of the most fundamental skills that we have. A 9% increase, as Alex told us, is 9% more than the original. So we have the original amount plus 9%. And I'd actually like to grab that and bring it down here. When we put those two things together, that's 109%. That is the percent of the original. Whenever you discuss a percent change, the original 100% is not included. Whenever you discuss percent of, the original 100% is included. A lot of our work is going to bounce back and forth between understanding percent of versus percent change. Next example. What percent change does 80% of correspond? Of course, the key characteristic here, if you have 80% of the original 100, what happened to it? We went from having the original 100, and now we only have 80. So what happened to it? Thank you, Dylan. Since we lost 20%, that's a 20% decrease. That's all. 80% of the original corresponds to a 20% decrease. Being able to convert back and forth between these two thoughts of percent of and percent change is a necessary skill. And let's complete this table. In order to complete the table, we're looking at what would you multiply by. When you work with a multiplication rule, it's typically based off of percent of. So if we were to gain 25%, how would you write out gaining 25% as under multiplication? It's common for students to say multiply by 0.25. Many students will say that. and they're wrong. Because multiplying by 0.25 is not gaining 25%, it's keeping 25%. So if you only keep 25%, that means you've taken away 75. 0.25 would be a 75% decrease, not a 25% increase. Dylan, you made the correct observation that since we need to keep the original 100 and gain 25 more, that's 100 plus 25, and 125% is 1.25. We would need to multiply by 1.25 to gain. For each of these or others, keep in mind we have to keep track of the original 100%. If we were to go down 15%, well, down 15 is keeping how much? No, this is not stacking. These are each individual problems. The student said it would be 35. Basically, we're looking at each of these as a different problem. If you go down 15% from the original amount, that means you're keeping 85%. And so if you keep 85, that means you have to multiply by 0.85. If a sale had something marked 80% off, how much are you keeping at 80% off? And so keeping 20%, that means you're 20% of the original. So 0.20, or we could quite simply just say 0.2, 2/10. What about up 9%? Well, we had the original increased by 9%. We actually did that one in example 6. What about a 10% discount? How much are you keeping with a 10% discount? Keeping 90%, so 0.90. I want to emphasize again, and I know I keep saying it because it's that important, your skill bouncing back and forth between percent of and percent change is critical. You must be able to do it well. Let's write this as a formula. M is 40% more than N. Well, we could quite quickly build M equals. How do we then continue it? With 40% more. Think back to what we were just doing on the table. How would you write out 40% more? That's multiplying by 1.4, or if you prefer, 1.40. 40% more is 140% of. And so we have 140% of N, 1.4 times N, and we're finished. Example 10. Shirts were originally priced at $40, and now they are $28. How much off are they? Although we did not write it this way previously, we did discuss in the last video the percent equation. And one of the ways in which many textbooks like to write the percent equation is based on a formula that the new value is the percent of, not the percent change, but percent of the old value. I didn't want to write that D yet. OLD. And I want to stress this again. When textbooks write down the percent equation, they are referencing percent of, not percent change, typically. Thus, we can use this equation to start building and say the new value is $40. The new was the original value. The new value is 28. The original value was 40. Thus, we can solve this equation simply dividing by 40 and converting that into a decimal. 28 divided by 40. That's 0.7. I want to pause and emphasize again. We know 0.7 is 70%. Was the price reduced 70%? No. When we work with this equation, we are working with percent of the original, not percent change from the original. If the price is 70% of, how much was taken off? That would be a 30% decrease. So actually answering the question, it's 30% off. And the last example for this video. At 20% off, a jacket costs $140. What was its cost originally? Well, we can still use that percent equation. We know the new value is equal to the percent of times the old value. So we would have to recognize the $140 is the current or the new value. What about the percent? 20% off, how would we write that as a decimal? But please keep in mind, 20% off, 20% is of course 0.2, but that's the percent change. Whenever we're doing these, we need to keep track of percent of. Thus, you correctly identified, we need it to have 0.8 multiplied by the original price. And so to solve it, we can simply get our calculators out to save us a bit of time. But dividing both sides by 0.8, we get the price value, 140 divided by 0.8 of 175. So it was a $175 jacket. That was our last example that we've had to go over. So please keep in mind the primary skill, the primary objective for this portion of the lesson for this subject. In order to keep track of change using multiplication, you will always have to be cognizant whether you are working with percent of or percent change.